Hi, I'm Shannon Seaver, and today we're going to be looking at Venn diagrams and set operations. This is part one of a four-part series. The agenda for today is to understand the meaning of a universal set, understand the basic ideas of a Venn diagram, and to use Venn diagrams to visualize relationships between two sets. So we're going to start off with a little bit of vocabulary. First of all, a universal set, which is denoted by a U. It is a set that contains all elements being considered in a discussion or problem. Here we have a Venn diagram. The Venn diagram shows the visual relationship among sets. So if you notice, the universal set is surrounded by a fence, so to speak. It's a rectangle. So U is within the rectangle of all the elements that we're talking about. And within this universal set, we have a smaller set called A. There may be more than one set within the universal set. You can have many sets. Here's an example. We're going to use the Venn diagram to determine each of the following sets. Here we have U, and everything within the rectangle is a member of U. So I'm going to list all of those here within these brackets. We have S, M, 5, square, and triangle. Inside of A, we only have square and triangle, so I'm going to write those in A. This says list the elements in U that are not in A. Well, we have these in A, so we need to look at everything outside of A but within the rectangle. So we have S, M, and 5. Now I want to give you a chance to try. Pause the video now and try this, and then turn back on the video to see if you got it right. In U, you should have gotten 7, 9, 1, 5, and 6. In A, you should have had 1, 5, and 6. And then the elements that are not in A but in U are 7 and 9. Let's represent two sets in Venn diagrams. There are 4 different ways of representing them. The first one is a disjoint set. This is when we have two sets inside the universe that have nothing in common. So they're completely separate from each other and they do not touch. In the second one, we have proper subsets, where we have a set B with a subset, a proper subset of A within it. In the third one, we have equal sets. They are actually A equals B, and it's just one circle. And then the last one, which is the one that most of you should be familiar with, is where you have two sets with some elements in common, where they kind of intersect each other. This is the one that you've probably seen most of the time. We're going to interpret some Venn diagrams, and we're looking at whether students are going to the homecoming game or the homecoming dance. Here, if I were looking at just this area right here, outside of the sets, those are the students that are going to neither the game nor the dance. The ones that are in set A, and I'm talking particularly into this set right here, looks kind of like the shape of a moon. Those students are going only to the dance. And the one that's in the middle, those are students that are going to both the dance and the homecoming game. And then the last one, the ones that are in this section, are the students that are only going to the homecoming game. that is the end of this video. Watch part 2 for more.